So one of the benefits of the future object is that you can have a result come back from an asynchronous task. Okay, you can submit a callable to an executor, get the future object back, and then you can kind of use that later whenever you want to examine it, all right? But the problem with the future object is always knowing when to look up the value. Okay, so we kind of struggled with this, and this piece of code isn't very elegant, right? The goal that we have is to have this go run on another thread. The calculation has to go run in another thread. But then after it's done, I want to do another action. Okay, the other action may not be asynchronous. In our case, the other action is basically to print it. And we don't have an answer to when we need to print it. Okay, so I can check if it's done, then print yes. But when am I going to do it? Ideally, what I'd like to do is I have to do this the instant the future has completed. Okay, so basically I'm sending this to something, and then I want to have some mechanism to say, hey, future object, I know that you're going to get filled when something is executed. You know, this particular callable returns a value, you are going to get a value. So rather than have me peek into you and say, is it done? If it's done, then do a .get and then do something with that .get. Is there some API where I can give a lambda and then have that API execute the lambda after a certain feature is done? Well, turns out there is an API for it, and that's something called completable future. Completable future makes this piece of code ridiculously simple. Now let me demonstrate how a completable future looks like. Okay, so I have a new class here, which is going to help me demonstrate the completable future concept. Okay, so here I am going to implement the same logic, but with completable future. Basically our whole prime number example, okay? So if I were to paste this piece of code here, which is looping and saying I'm going to calculate the nth prime number, gets the integer, if n equals 0, break. But now instead of doing all this stuff, instead of doing any of this stuff, what I'm going to do is I'm going to use the completable future API. So the completable future API looks something like this. Completable future has a static method, which is basically called supply async. Okay, so what supply async takes is a lambda. I can give it a supplier, basically any lambda that returns a value. Okay, let's say this, hello. So what this is going to do is it is going to execute whatever lambda I pass in a separate thread, and it's going to get the value. Now, the thing is not that it executes this in a separate thread. This can be done, but the idea is that you can tell this thing, hey, I gave you a lambda to execute in a separate thread. Once that lambda returns a value, this is a supplier, it returns a value, right? So once it returns a value, well, I'm going to give you another lambda, just call that with that value, all right? So what I'm going to do is I'm going to say dot, then accept. Okay, and now here I can pass in any lambda, which is going to take this as an argument, like whatever this thing returns, it's going to be passed as an argument over here. So let's say I can do a string s, which is basically what this thing returned, and now I can do system dot out dot println of s. Okay, so what I'm saying here is first run this lambda asynchronously, that's supply async. Run this lambda asynchronously. This is a supplier, so it's going to give a value back. Now what I want you to do is take that value and pass it as an argument to the second lambda. So now what I've done is I've said first do this and then do this. I've told this to completable future, so I don't have to actually check when this returns a value. I already have told it the next thing to do. Okay, so if I were to run this thing, it is going to execute this first thing. It's going to ask me for enter something, this doesn't matter, but here it executed this hello, right? So what it's doing is it's going to first execute this lambda in a separate thread. Okay, and then once it returns, this might return immediately, or this lambda might take a lot of time to return, whatever it is, right? Once it returns in that same thread, it is going to pass it as an argument to the second lambda. Right, so you can see the benefit of this thing. Now what I can do is I can take this value here, like when somebody returns, when somebody enters an n, I can just use that and say, rather than returning a string, what I'm going to do is I'm going to do a prime number util dot calculate prime of n. Okay, so now what I'm going to get back over here is going to be a integer n, or maybe I'm going to call it return value, and I'm going to send it to system.out.println of return value. Okay, now you see how powerful this is. Now I don't have to stick around for when this gets calculated. I don't have to get a future object and then check if it's done, and only when it's done execute system.out.println. I've just told it, hey, just see when it returns, and then after that just do what should be done, right? We'll execute this lambda. Simple. Now if I were to execute this, we have basically replicated all of that functionality about running this in a different thread and getting the, the future object back. This is going to do it all. Okay, so this prime number calculation is happening in a completely different thread, and in that same thread it is executing this thing. I don't have to wait for it to come to the main application thread. I'm basically passing an additional instruction to the thread that actually runs it so that it can do the right thing. Okay, so if I were to enter a large number, it is going to keep executing it, but it doesn't block me. Okay, let me enter a slightly larger number. It doesn't block me. I can still continue and get the value. This thing is caused some thread to run, and that thread has this as the next thing to do. Okay, I've already sent it. So every thread that gets spawned over here is going to have the next thing to do already programmed. So it is going to do the next thing. Okay, so this doesn't entirely take the place of getting a future object and then doing done on it, because again, notice here, instead of getting the value to the main application thread, you're basically sending a lambda to the thread that is spawned by this. It's a completely different approach, but for our use case, you can notice how easy this is to do something like this. All right, and since it's lambda, instead of just doing this, and since I'm passing a value, I can just use a function reference like this to make our code even more simple. Okay, so this is yet another way to implement our prime number example, but this time using completable futures, and you're going to get the same experience. Now you might be wondering, well, this is creating this in a new thread, but where is this actually being run? Is it in a thread pool? Is it somewhere else? Well, before we talk about that, let's say you have a thread pool and you want to use completable future to leverage that thread pool. Well, you can actually pass that in here. Okay, so I can create a executors.new fixed size thread pool of, let's say, 2. Okay, and now I can hold on to this in a local variable, and then I can pass the executor service as the second argument to the supply async. Now what happens is this supply async is going to take your lambda and find a thread in this thread pool to execute, and then it's going to say in that same thread run this after, right? So you're leveraging the thread pool that you created. Okay, if you want to have control over where the thread runs, where this lambda runs, you can pass in an executor service instance. But if you don't do this, you use a common thread pool which is shared by your application, which is something called a fork join thread pool. I'm going to talk about what fork join is later in this course, but it's rest assured that it is a thread pool which is made available to your application, to all Java applications, and it is kind of like a common thread pool that you can use. It doesn't have a limit as such, so you get the benefit of, you don't have to worry about like, okay, did someone else take threads from that thread pool? So it is going to do the right thing, and it is, at least it's the default way of sending lambdas to completable futures. When you supply async, it is using that default fork join thread pool, but you can pass custom thread pools as well. So this is completable future, another powerful API for working with threads, where you can kind of pre-program what needs to happen in a thread and then what needs to happen after the thread is done, so that you don't have to mess with future objects and checking if that future object is done or not.